Okay, in this video, which might be the last one on the ONS system, I'm going to look at Chapter 12, which talks about DWDM node configurations. Basically, we've been through 11 chapters in this configuration guide and just seen one chapter after another talk about specific types of cards. This chapter shows you how to bring those cards together into the various configurations at nodes. There's actually a chapter later on which shows you how to do entire networks of nodes, but we're going to stop here with learning how to provision nodes and get the idea basically on how to do this. So basically the big picture is that the 454, the ONS 15454 supports the following node configurations: hub, terminal, optical add drop, multiplexing, OADM, reconfigurable OADM, ROADM, anti-amplified, anti-ASE, amplified spontaneous emission, line amplifier, optical service channel regeneration line, multi-shelf nodes, and node configurations for mesh networks. So there's a whole bunch of different types of nodes possible. I guess the very first one to look at is what's called a terminal node. And a terminal node is one that takes a bunch of client-side equipment. That is, we talked about client-side equipment in the last video, where we've got a whole bunch of client-side possible signals like different SONET signals. Here's the list of client signals: OC48 digital video, gigabit fiber channel, gigabit Ethernet, OC12, OC3, some more video types. Okay, so a terminal node takes client-side signals and puts them onto the DWDM system, basically. Okay. And in this chapter, they not only describe the nodes, but they give you an example configuration of what the main shelf would look like to configure that node. So they show you the picture of it here. They also then show you the block diagram of that node. We've seen one of these before in one of the videos where we have a block diagram that includes multiple cards in it. And so it's essentially, for instance, here's a BST card, here's a PRE card, optical amplifier cards, here's DCUs, here's a 4MD channel drop card, here's an AD1C and an AD band add drop, here's a channel add drop. These are all different cards, and these types of flow diagrams show how all these cards are put together to create a node. Okay, so this is an example of an OADM node. Okay, so this is an optical add drop multiplexing node. So for instance, in this node you can see, hopefully you're fairly well familiar with this by now, that we have bidirectional capabilities. We have a line in here, and the very first thing that happens on that line in is we pull off the optical supervisory channel, and then we send it into an optical preamp with mid-stage dispersion compensation. Then we send it to whatever series of add-drop multiplexers we want. Here they're showing a band, an add-drop band multiplexer. Here they're showing an add-drop channel multiplexer. Here they're showing another channel multiplexer. Here another band multiplexers. The band multiplexers have to go to demuxes to get out to individual channels. Okay, and after those multiplexers, it goes out to an optical boosting amplifier and finally out on the line after our optical supervisory channel has been multiplexed back in. Same thing happens going in the other direction. And so hopefully you're familiar with this at this point, and see how that works. Here's the next one that they give as an example of a ROADM node. Guess what? It looks exactly the same as the OADM node, the OADM node. They show an example of the shelf configuration. Oh, I'm sorry, it doesn't look exactly the same. Well, we'll see. It's much the same. Let's follow it through here. It doesn't quite even fit on the slide, does it? There we go. We've got bidirectional operation again. We've got side B, line in, and side A, line in. And the first thing we do is we pull off the optical supervisory channel. Then we send it to a preamplifier. Then we send it to a splitter. And now it's that splitter which is simply demuxed to give us our drop channels. Then we send it to an OAM, a wavelength selective switch with an optical add multiplexer to it where we can add channels, and then we finally mux in the optical supervisory channel again. So it really is functionally much the same here, except we're using, instead of these individual add-drop multiplexers, we're using these two wavelength selective switches with demuxes on the drop side, and simply adding. They don't show the detail here on the channel addition. The reverse direction is just the same, so it's really the same basic idea on an optical add-drop node. Here's an example of the shelf configuration with the wavelength selective switch cards in it from this example. Here is a hub node example. Okay, a hub node is the very simplest one where we've got a bunch of client equipment. We've got a bunch of SONET gear, in other words, and we have gigabit Ethernet and SONET OC3s, OC12s, and OC48s, and maybe some digital video coming in and going out. And basically what we're doing is we're adding those using multiplexers. The client equipment includes all of those cards from Chapter 11, which turns the client signals into DWDM signals, and then it takes those DWDM signals, multiplexes them, puts them through a booster amplifier, and sends them on their way towards the east. It also accepts inputs from the east, gives an optical preamplifier with dispersion compensation, demuxes them for the clients. Okay, same thing on the west side. Okay, and the whole thing with the optical supervisory channel being pulled off and then put back on is all the same here. But this is a hub node where we've got a lot of client equipment here, which is connecting to probably lots of office buildings and that sort of thing. Okay. This chapter also includes how to make a mesh node, and this is a single piece of a mesh